Alright, let's look at the homework 4.5, problem number 6. Alright, so we want to sketch the graph of y equals e to the negative x times cosine of x. Alright, from x going from 0 to 2 pi. Alright, so let's do that. Alright, so first we need to look at the original function y. So number 1, let's look at the original function y. Alright. Then the domain, domain is restricted between 0 and 2 pi, so we know that. And let's find the y-intercept, right? So y-intercept, right? So which means that the we're gonna set x equals 0. Right, so which means that let's see, y is going to be equal to e to the 0 is 1, cosine of 0 is 1, so 1 times 1, so y-intercept is 1. Alright, then x-intercept. Alright, so we set y equals 0. So we know that the cosine e to the negative x cosine of x equals 0. Alright, since e to the negative x is never 0, it's actually positive. So only way we can make this guy equal to 0 is the cosine is 0. So cosine is 0 when x equals pi over 2. And also a 3 pi over 2. Right? So we have two x-intercepts between 0 and 2 pi. Alright, then let's see, maybe we should look at that there's no vertical asymptote or horizontal asymptote. Actually, I was wrong. There's a horizontal asymptote. If you look at the limit as x approaches infinity of e to the x, which e to the negative x, so I'm going to put the e to the x on the bottom, and the cosine of x. Right? We can find this limit because cosine is between negative 1 and 1, so we can look at the cosine of x is between negative 1 and also a positive 1, right? And if you divide through by e to the x, and you can see that as x approaches infinity, this guy approaches 0 because e to the infinity is large. Negative 1 divided by a big number, it's going to approach 0. And this guy also approaches 0. So by squeeze theorem, this guy is equal to 0, which means that there's a horizontal asymptote, which is y equals 0. Right? So since we are restricting a domain between 0 and 2 pi, so we won't be able to see it clearly, but there is a horizontal asymptote, which is the x-axis. Alright, so now let's look at the first derivative. So you have number 2, we're going to look at the first derivative. Alright, so take the derivative, so y prime is equal to, right, so we have to use the product rule. So this is the first guy, this is the second guy. Right, so derivative of e to the negative x is negative e to the negative x, and times the second guy, which is cosine of x, and plus first guy is e to the negative x, times derivative of cosine is negative sine of x. Right, so if you pull out the negative sign and e to the negative x, so negative e to the negative x, we can see that it's going to be simply cosine of x plus sine of x. Alright, so let's set this guy equal to 0 to find the critical number. Alright, this might be a little bit tricky because we want to say set, so this guy is never 0. So we have to set this guy equal to 0. So we have cosine of x plus sine of x equals 0. So which means that let's say we can just put the cosine on the other side. So it's a sine of x is equal to negative cosine of x. Right? So what kind of x value would satisfy that equality? All right. So I'm going to draw a unit circle here. Try to figure it out. All right. So here's the x-axis, and here is the y-axis, and this is the origin. And then you have a unit circle and something like that. Alright, so we know that this is 1 here, 1 here, and negative 1 here, negative 1 there. Alright, then remember that the point on the unit circle, x coordinate is represented by cosine and a y coordinate is represented by sine. So in a way, we have so sine is represented by y, cosine is x. So this is y equals negative x, which is the equation, which is the line right here. So this is the equation where x value and the y values are opposite sign but the same magnitude. So we're talking about these 2 points, right? That's where sine of x equals negative cosine of x. Then you see that the angle here is 3 pi over 4, right? And also the angle all the way to there is 7 pi over 4, right? So we know that this will give us 2 x values, which is 3 pi over 4 and 7 pi over 4, right? So those are the critical numbers, right? So we can do increasing, decreasing analysis from there. All right, I would like to do a number line along with the second derivative. So let's go ahead and find the second derivative. So let's see, I'm going to put the 3 here. All right, so this is y double prime. All right, so we can find out about its concavity. All right, so another derivative. So we have to take the derivative of this guy. So y double prime is equal to, right, so this is our first guy and this is a second guy, right? Derivative of the first guy is e to the negative x, negative sign cancel out, and then second guy multiplied by cosine of x plus sine of x, right, plus, right, so actually it's going to be a minus e to the negative x times derivative of that, which is negative sine of x, and the derivative of sine is positive cosine of x. All right, so you can see that we can cancel. Let's see, there's a cosine here minus cosine, so you can cancel those. Then this is a double negative, so it's addition, so you're going to get it's actually 2 times e to the negative x sine of x, right? So we're going to set that equal to 0. We can get, so we want the sine to be 0. So it's going to be between 0 and 2 pi. So it's going to be 0 and pi and 2 pi. All right, so those are the possible places where you would have inflection point, a possible inflection point. All right, so let's do increasing, decreasing, and the concavity analysis together. So we will have, all right, so we're gonna have that. So here's the x, and it's only between 0 and 2 pi. Maybe I should just start from here. So here, this is 0, and this is 2 pi right there. All right, so let's see, we have a 0, 1, so I'm gonna put pi here too. All right, then here is the I'm gonna put the y prime down here, a y double prime, and a y prime above the number line. Right, so this is easier, so I'm gonna just look at the second derivative concavity first. All right, so we can try anything like less than pi. So I'll try, let's say, pi over 2. Right, sine of pi over 2 is a positive 1. Everything else is positive. So we know that we have a positive sign here. All right, so maybe I'll use so positive here. All right, after pi, so I'm going just to put a little divider here. After pi, so we can try like 3 pi over 2, right? And sine of 3 pi over 2 is negative 1, so it's going to be negative here, right? So I'm going to use the red here, so it's a negative here, right? So it looks like on first half it's concave up, second half is going to be concave down. All right, so increasing, decreasing analysis, we're going to have to put the tick marks at 3 pi over 4. So that will be, so this is a half, and here. This is 3 pi over 4 there. All right, then after that, it's a 7 pi over 4. So I'm going to put, let's see, so I'm going to put the 1/2 here and quarter there. So it's so this is 7 pi over 4, right? Right. So we can just try, say, anything before 3 pi over 4, so like a pi over 2, right? So if you put pi over 2, so cosine of pi over 2 is 0, sine of pi over 2 is 1, and there's a negative sign, so it's going to be negative. So we have a negative sign here. All right. And between 3 pi over 4 and 7 pi over 4, I'll try pi. So cosine of pi is negative, sine of pi is 0, so that's going to be negative, negative, so it's going to be positive here. All right, then after that, we can try, let's see, anything after that, like a 2 pi or something like that. If you try 2 pi, sine 0, cosine is 1, so it's going to be negative here. All right. So we can see that the graph is going to be, here, it's going to be concave upward here, and a concave downward after that. And here, it's starting out with decreasing here, and increasing here, and decreasing there. All right. So let's try to use this to sketch a picture, right? Actually, let's go back and see if this one fits one of the graphs given here. All right, so I'm going to go here. Oops, this is not what I want. Actually, this one. All right, so you have a decreasing, increasing, decreasing. All right, first one doesn't fit the bill. All right, this one decreasing, increasing, so that doesn't fit the bill. And decreasing, increasing, and it looks like it's start to decrease here. So this looks promising. This one is actually increasing. So actually, the only one that fits that description is this one. All right. So let's check other things. So we have a decreasing, increasing, decreasing behavior. So we got that. And also we have X-intercepts. We found the X-intercept to be pi over 2. And a 3 pi over 2. All right, let's check that. All right, so you have a pi over 2 here and the 3 pi over 2. So we have X-intercepts. All right. y-intercept is 1, and unfortunately I don't think it shows here, but it looks like it's gonna go up and hit 1. So let's take that as you know, the correct. And then concavity, and if you check the concavity, it's first half is concave up, second half is concave down, and so you have here concave up, and after pi it's concave down. So it looks like it's following the pattern, and definitely this is the only one that fits the bill. Alright, so let's double check. Alright, submit for testing. Alright, it came back, and looks like we got the correct picture. Alright, so that's it. I hope that this was clear.